Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss ionization of big bases. Last class I have discussed about pH scale. pH, how will determine the pH, that I have discussed. What is the pH I have discussed. Now I am going to discuss the ionization of big bases. It is just like ionization of big acid. Both are very similar. All things are similar. Just I will brief you. Okay. The ionization of base, big base, just base you can consider as a MOH, capital MOH, MOH. Then like acid, you can also write the can say Kb value. For acid it is Ka. A means acid. Here Kb, B means base. Then dissociation constant of base of the big base, like MOH in aqueous solution, MOH, that will give M plus OH minus. All are in aqueous solution, AQ. Then MO dissociates and gives M plus ion and OH minus ion. All are in aqueous. In a big base, there is a partial ionization of MOH. Partial, not fully. Big means always partial. Then in a weak base, there is a partial ionization of MOH into M plus and OH minus. The case is similar to that of acid dissociation equilibrium. The equilibrium constant for base ionization is called base ionization constant and is represented by Kb. It can be expressed in terms of concentration in molarity of various species in equilibrium by the following equation. Means Kb is equal to molar concentration of M plus into molar concentration of OH minus divided by molar concentration of MOH, just like Ka. Means a product product's concentration divided by reactant concentration. Okay, the product concentration divided by reactant concentration. Same way like Ka. Okay, or also you can write Kb is equal to, suppose M plus ion is a this thing, concentration of MOH. Suppose it is the C mole per liter, initial concentration C mole per liter, and at equilibrium suppose alpha mole dissociated, then at equilibrium it will form C alpha of a metal ion and C alpha of OH ion, and from the initial concentration C, now C alpha dissociated, C alpha, alpha is a degree of dissociation, then at equilibrium what will remain? C minus C alpha. Last class I have discussed same way. In the case of, you can say ionization of weak acid, same things here. Then at equilibrium C minus C alpha will remain and M plus will be C alpha and OH minus will be again C alpha, because in balanced equation MO is giving M plus and OH minus, only 1 mole each. That's why it will form C alpha of metal ion, C alpha of OH ion, and MOH will remain C minus C alpha, because C alpha dissociated. Then This in another way, Kb value you can write, that is Kb is equal to C alpha into C alpha divided by C minus C alpha. Same way as big base. Now again here same thing will do. Down in denominator C into C alpha is there. So you can take common. Then 1 minus alpha will remain in bracket. Okay. Then 1C denominator and 1C up, that is will be cancelled. Then it will remain C alpha square divided by 1 minus alpha. Okay. Then this is the another way, and it is just like a formula also you can tell. Kb is equal to C alpha square divided by C 1 minus alpha, and C will be cancelled. Then that will be final will be C alpha square divided by 1 minus alpha. This is equal to Kb. In solving the numericals, this relation will be used. And here also I will tell some values, some you can say Kb values of some big bases. As for example, we can say dimethylamine. Dimethylamine means CH3 whole 2 NH. Ammonia is there NH3, na? 2H replaced by CH3. Then it becomes CH3 whole 2 NH. It is called dimethylamine. It is a weak base. Question is also asked. Then its Kb value is 5.4 into 10 to the power minus 4. And triethylamine, in the place of methyl, now ethyl you have just NH3 was there, all H you have can say replaced by ethyl group. It became C2H5 whole 3 N, and it is a weak base, and its Kb value is 6.45 into 10 to the power minus 5. And ammonia, always remember, ammonia NH3 or NH4OH also you can tell, because NH3 plus in water OH ion it will take and it will form NH4OH. Then ammonia or NH4OH, its Kb value is 1.77 into 10 to the power minus 5. Quinine, a plant product, quinine, it is used as a medicine also. Okay, drugs, it is actually drugs. Quinine, it is base. Then quinine, and its Kb value is 1.10 into 10 to the power minus 6, very weak base. Pyridine, that is a C5H5N, that is a pyridine. It is also big base, and its Kb value is 1.77 into 10 to the power minus 9. Aniline is also big base. Question is asked, all are very important. Aniline is a big base, C6H5NH2. Kb value is 4.27 into 10 to the power minus 10, very weak. And urea CONH2 whole 2. CO, C double bond O, and one side NH2, other side NH2. Okay, then it is a CONH2 whole 2, and its Kb value is 1.3 into 10 to the power minus 14, very weak base. Already I told you that Kb value is more means strong, Kb value is weak, Kb value is less means weak, means it is a weak base, and if Kb value is more, then a strong base, just like acid, a strong acid and a strong strong base. Okay, then now I have told you about the ionization of big base. Okay, now again you can see further many organic compounds like amines, Like amines are weak bases. Amines are derivative of ammonia. Don't forget, amines are derivatives of ammonia, in which one or more hydrogen atoms are replaced by another group. For example, methylamine, codeine, 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 quinine, and nicotine all behaves as very big bases due to their very small kb. Ammonia produces OH in aqueous solution. Ammonia produces hydroxyl ion in aqueous solution, means NH3 plus H2O, NH3 aqueous plus H2O liquid. It will form ammonium ion aqueous plus OH minus aqueous. Okay, NH3 plus H2O, that is equal to NH4 plus OH minus hydroxyl ion. The pH scale for the hydrogen ion concentration has been, you can say, extended to get pKb value. pH scale, pH value, know that pH is equal to negative logarithm of hydrogen ion concentration. Like that way, pOH value will be there. pOH is equal to negative logarithm of hydroxyl ion concentration. In the place of H ion concentration, here OH ion concentration you will write OH minus. Then pOH is equal to negative logarithm of hydroxyl ion concentration. Okay, and also just like pKa, pKb is equal to minus log Kb. pKb means what? pKb means P means, I told you, minus log. Then minus log Kb, just like pKa, P means minus log, then pK is equal to minus log Ka. Log always base 10. Okay, don't forget. Then I have told about the ionization of big bases. Now I am going to tell a very important data I am giving you, that is used in all examination, all competitive examination it is asked. Okay, then here that is related to pH value of some common substances. All should know actually, particularly a student should know, and it is asked in examination also. Then I am telling you saturated solution of NOH. NOH solution, what is pH value? Then we know that the maximum value is 14. Maximum value is pH value is 14 at 25 degree. But here in this case solution is saturated, fully saturated. Hence its pH value is just equivalent to 15, near about 15, 15, more than 14. Okay, more than 14, roughly 15 you can tell, because it is saturated. And 0.1 m NOH solution means m by 10, molarity divided by 10, 0.1 m NOH. Its value is 13. Basic, all are above 7, all are basic, below 7, all are acidic. Then now lime water, its value is 10.5. It is also basic, but comparative to 0.1 m NOH it is less, 10.5. Milk of magnesia, magnesium hydroxide is called milk of magnesia, just like lime water, calcium hydroxide, aqueous calcium hydroxide, 10.5. and milk of magnesia, magnesium hydroxide, that is the 10, its value is 10. Egg white, egg you have seen, na? White, egg white or sea water, you can tell, both have same 7.8. pH value is 7.8. Either egg white or sea water, both are same, 7.8. Human blood, it is 7.4. milk 6.8, human saliva 6.4, black coffee 5.0, tomato juice. Now here you can see from the here human blood I told you 7.4, little basic because it is coming close to 7, hence 7 is neutral, you know. Water is a neutral, 7, but rainwater have a little basic, you can tell, around 7 only, okay, but neutral water is 7, and human blood I told you 7.4, milk is 6.8, means little acidic, rainwater 7.2, little basic, 7.2, okay, little variation is there in water, okay, little you can say acidic sometimes, near all will be near just 6.8, 6.9 like that, 6.8 you can think, okay, rainwater 6.8, sometimes very little variation is there, it will be more than 7 also, 7.2, but generally it will be rainwater will be acidic, okay, then that is the 6.8, human blood 7.4, okay, milk is little acidic 6.8, human saliva also little acidic 6.4, black coffee 5.0 acidic, tomato juice 4.2 acidic, okay, soft drink and vinegar, it is acidic, roughly 3.0, lemon juice roughly 2.2, gastric juice acidic 1.2, means more acidic, they are coming very less, closing to the near the 0, means very acidic, the lemon juice 2.2 roughly acidic, gastric juice 1.2 acidic, and 1 mHCl molar, its value is near about 0, very high, you can say pH value is 0, means very high acidic, and concentrated HCl 1.0, concentrated HCl 1.0. Then this I have given idea of some, you can say, common pH of some common substances. Now I am going to tell about the relation between Ka and Kb. Ka and Kb, you know, both are similar, only K is used for the acid, weak acid, and Kb is used for weak base. Again I am telling you, K is telling, by seeing the value of K, what is the importance of Ka? By seeing the value of Ka, you can understand that acid is strong or weak, or base is strong or weak. If it is more value, then strong, weak value means weak. In both cases, in case of acid and in case of base, it applies, okay. Then what is the relation between K and Kb? I am going to tell, because in solving the numericals, this concept will be used. Relation between K and Kb will be very useful, okay. Many times relation is also asked in examination. Then by example you can understand. Then I am giving examples of ammonium and ammonia. Ammonium and ammonia, both example I am telling you. Means ammonium, you know that it will behave like acid, ammonium NH4 plus, because it can donate the H ion, it can donate the H plus ion, that's why it is a acid. And NH3 behaves like a base, because on nitrogen lone pair of electron is there, one lone pair of electron, then it can donate Then that's why ammonia, always you keep in mind, is a base. And ammonium ion, NH4, it can donate H+. That's why it behave as a acid. Okay. Then now, just with the example of ammonium, first example of ammonium, you understand. Ammonium ion, NH4+, NH4 plus H2O. H2O. I told you H2O behave like acid as well as a base, big acid and big base. Then here ammonium ion donates the hydrogen, proton, H plus, means that is called proton. It donates the proton, and now H2O will take, means it is behaving like acid now. Acid, it will take H plus. Okay, and NH4 will give H plus. Then here H2O will take H plus. Then what will happen? It will form hydronium ion. Hydronium ion. Okay, plus ammonia, because NH4 plus H plus is donated. It has donated H plus. Then now NH3 is remaining. Then conjugate, you can say base. Conjugate base will be ammonia of ammonium. Okay, ammonium became ammonia. This was the acid, now it became base. And this H2O has taken H plus. Then now it became hydronium ion. Then NH4 became NH3 and H2O became hydronium ion. Then for this relation, Ka will be what? Then it will be concentration of products divided by concentration of reactants. Means molar concentration of H3O into molar concentration of ammonia divided by molar concentration of ammonium. In a simple way, what we have been writing, same way. Then for in this case, in case of ammonia, Kb value is actually 5.6 into 10 to the power minus 10. This also you remember, 5.6 into 10 to the power minus 10. This is the Kb value in case of ammonium, NH4 plus. Now just you think for these things, hydrolysis of ammonia, means NH3 plus H2O. Also ammonium hydrolysis also you can tell, and now I am telling ammonia hydrolysis. Then H3O plus H2O. Then again it will give ammonia because it is the base. It will take hydrogen. It will take hydrogen from the water and it will convert to ammonium ion, and H2O will convert to OH. Then here H2O behaved as a acid because it has given H ion to ammonia. Ammonia has taken and converted to ammonium. Okay, then ammonia was base and its conjugate acid is ammonium ion, and H2O was here acid. Now H2O became OH minus. Okay, then this is the conjugate base for H2O. Then this I have told for ammonia. Now in this case also, because ammonia is a base, then Kb. What is the Kb for this? Then same way means products, concentration of products divided by concentration of reactant. Then here products you can write molar concentration of ammonium into molar concentration of OH ion divided by molar concentration of NH3. Then its experimental value, Kb value for ammonia hydrolysis is 1.8 into 10 to the power minus 5 in both cases. Not in both cases. First case Kb was there, for in the case of ammonium Kb value was 5.6 into 10 to the power minus 10. And now here Kb is equal to 1.8 into 10 to the power minus 5. Minus 5 is more. 10 to the power minus 5 is more than 10 to the power minus 10. Hence you can tell ammonia is more basic than ammonium ion. See the benefit of Kb. Then K and Kb, for both I told you. For ammonium ion, it is a 5.6 into 10 to the power minus 10. And for ammonia, it is the 1.8 into 10 to the power minus 5. And expression is very simple way. You can write, after writing the expression, quickly you can write the expression for K and Kb. That is always, you don't forget that upside you write molar concentration of products, and down always you write, you can say this molar concentration of reactant. Okay, then for any reaction you can write the K value. Here it is called K and Kb. Okay, dissociation constant of acid, and Kb is dissociation constant of base. Now Kw already you know. Then what is the Kw? Three relation I am telling you, Ka, Kb and Kw. Then Kw you know, for the 2 moles of water, H2O plus H2O, it will form H3O into OH minus. Already you know. Molar concentration of Kw is equal to molar concentration of H3O into molar concentration of OH minus. Then you can also tell Kw is equal to molar concentration of H ion into molar concentration of OH ion. H ion you can write H3O plus also, H plus also. Both ways it is accepted. And Kw value you know, that is the 1 into 10 to the power minus 14 m. 1.0 into 10 to the power minus 14 m, or simply 10 to the power minus 14 m also you can write. Then this is the value of Kw. Then what is the relation between K and Kb? Then very easy. Ka expression you write into Kb expression you write. Then what you will see, all will be cancelled. And what will remain? After cancelling? Then only H3O and molar concentration of H3O and molar concentration of OH ion will remain. Upside, all will be cancelled. You can check it. Actually, whenever you are attending the class, you sit, you just keep with you can say pen and paper. Okay. Then here K into Kb, write the expression of K. That is the K expression is H3O, molar concentration of H3O into molar concentration of NH3 divided by molar concentration of ammonium. This is for K. And for Kb, molar concentration of ammonium into molar concentration of OH ion divided by molar concentration of ammonia. Then all will cancel except hydronium ion and hydroxyl ion will remain upside. Only these two will remain. And H3O into H3O concentration means hydronium ion concentration into hydroxyl concentration, that is equal to Kw. Then now we got the relation very easily. K into Kb is equal to Kw. Ka into Kb, that is equal to Kw. This is the relation between Ka, Kb and Kw. Very, very important relation I have told you. In numericals, when you will solve the numericals, that time you can say this formula you need. Okay, this is very important formula. K into Kb is equal to Kw. And now K and Kb, now you can put the value of these things. Hydronium ion into OH ion, that is equal to Kw. Okay, means K into Kb is equal to Kw. But if you will write in this case, in this case, if you write the value of K into Kb, then K value I told you 5.6 into 10 to the power minus 10, K value, okay, and Kb value I had told you that is the 1.8 into 10 to the power minus 5. Then if you will solve all the things, then you will get 1.0 into 10 to the power minus 14. That is the Kw value. K value you have put and Kv value you have put. Already I told you that this value you have put. Then after solving, automatically you will get 10 to the power minus 14. That is equal to Kw. Then here you can see 10 to the power minus 10 and 10 to the power minus 5. Okay, but before that 5.6 is there. 5.6 into 10 to the power minus 10 into 1.8. 1.8 into 10 to the power minus 5. After solving, you will get 10 to the power minus 14. That is the Kw. Then this I have told you the relation. Then here this can be extended. This relation, this can be extended to make a generalization. The equilibrium constant for a net reaction, what we got na, K into Kv, that is equal to Kw, that is the net reaction. Okay, the equilibrium constant for a net reaction obtained after adding two or more reactants equals to the product of the equilibrium constant for individual reactions. Means K net, again I am telling you, listen, the equilibrium constant for a net reaction means you are considering more reaction, okay, maybe 2, 3 more also. The equilibrium constant for a net reaction obtained after adding two or more reactions equals the product of the equilibrium constant, product of the equilibrium for each reaction. For each reaction, equilibrium constant will be there. That here it is going. I am going to tell. Then the equilibrium constant for a net reaction obtained after adding two or more reactions becomes equal to the product of the equilibrium constant for individual reactions. Suppose 3 reaction was there, and then K1 into K2 into K3, that is equal to K net. That is called K net. 3 reaction was there. Then for first reaction K1, second reaction K2, third reaction K3, then K1 into K2 into K3, that is equal to K net. Similarly, in case of conjugate acid-base pair, same things. K into Kv is equal to Kw. Knowing one, if out of 3, 2 are knowing, third you can automatically know. K into Kv is equal to Kw. If out of 3, 2 you are knowing, third you can know very easily. Knowing one, the other can be obtained. Again I can tell third means Kw value is fixed, 10 to the power minus 14. Hence, if you are knowing Ka, then Kv you can know. If Kb you are knowing, then Ka you can know, because Kw value is known. The knowing one, the other can be obtained. It should be noted that a strong acid will have a weak conjugate base and vice versa. Okay. Then this I have told you. And in general way also you can write that suppose B aqueous, okay, B aqueous plus H2O, okay, then it will form BH plus OH minus. And for this, what will do the Kv value here, capital B aqueous plus H2O, then it will give BH, capital B H plus, okay, plus OH minus. Then for this, Kv is equal to what? Products divided by reactants, molar concentration of product divided by reactant, means molar concentration of BH into molar concentration of OH minus divided by B. Okay, this is the, you can say, I told you in general way it is written like that. Then now when you are knowing Kw is equal to K into Kb, then now you can multiply everywhere by P. By P means minus log. Then you will get minus pKa plus pKb, that is equal to pKw, and that is equal to 14 at 298 Kelvin. This is the another relation. Ka into Kb, that is equal to Kw. Now minus log you multiply everywhere. Minus log Ka. Okay. After that again into is there, minus log Kb, that is equal to Kw. Then in the place of minus log Ka you write P. Then it will come pKa plus pKb, that is equal to pKw. pKw, that is 14. Okay. Then if we take the negative logarithm of logarithm of the both side of the equation, then pKa value of the conjugate acid and bases are related to each other by equation, that is the pKa plus pKb, that is equal to pKw, that is equal to 14. Okay, this I have told you about the relation between pKa, this K and Kb. Now numericals are there, that also here I want to discuss. Okay, numericals. The numericals are based on, you can say, concept what I have discussed. Okay, then I am telling you these things, numericals. Many problems are there. Just first numericals I am telling you. First problem is that the concentration of hydrogen ion means H plus. Okay, the concentration of hydrogen ion in a sample of soft water is 3.8 into 10 to the power minus 3m. What is its pH? Then okay, it says formula is, you are knowing, pH is equal to negative logarithm of hydrogen ion concentration. Then hydrogen ion concentration value is 3.8 into 10 to the power minus 3. Then you put the value, then you will get minus log and hydrogen ion concentration you can write 3 into 10 into 10 to the power minus 3. Then minus log is outside, and in bracket it is 3.8 into 10 to the power minus 3. Then I told you log x into y, log inside x into y, then formula you know that log x plus log y. Then here also 3.8 into 10 to the power minus 3, it is in bracket, outside log is there, minus log. Then it will be, you can just elaborate it, then minus log 3.8. okay, and again it will be minus log 3.0. Why? If 3.8 into 10 to the power minus 3 is there, outside log is there, then now separate it, then you can write minus log 3.8 plus log 10 to the power minus 3, because outside minus is there, then minus will come plus. Okay, then now after that you have separated minus log 3.8 plus log 10 to the power minus 3, because outside minus was there, that's why minus become plus log 10 to the power minus 3. After that take From the chart, periodic chart, you can see the value of log 3.8. Then its value will come 0.58. Then minus 0.58 plus log 10 to the power minus 3. Then minus 3, that will come in the front. Then log 10 is equal to 1, and it will become minus 3. Then minus 5.8 minus 5 minus 0.58. 3.8, it's this value will come 0. Log double, will see it, then its value will come 0.58. Then minus 0.58 and minus 3.0. Then after solution, it will come 2.42 plus 2.42. Therefore, the pH of the soft drink is 2.42, and it can be inferred that it is acidic. Soft drink is actually acidic. Okay. Then actually this log this formula is there, log in bracket x into y, that is a log x plus log y. It is useful. Okay. Now next problem I am telling you, calculate pH of a 1 into 10 to the power minus 8m solution of HCl. Okay. Then here in theory also I have told you, because HCl is a strong acid, hence you have to consider, you can't put directly in the formula. Hydrogen ion concentration they have given, then you can't put directly in the formula, that will be wrong. Okay. Then here what is these things, I am telling you important things. Here pH value is given 1.0 into 10 to the power minus 8. Okay, 8m. Then what is the pH value? It looks very simple, but it is not simple. Here you have to consider hydrogen ion concentration of H2O plus H2O. In water, in water H will have H2O plus H2O hydronium ion plus OH minus. Then or simple way, H2O breaks into H plus and OH minus. It breaks into that. Then H plus ion is given by the water also. By water also H ion is given, and HCl is also giving H ion. Hence total H ion you have to consider. Then pH will change. If you write it direct what they have given question, then it will be wrong. Okay. Then here same concept you are going to use. Then you are knowing that 2H2O, that is H3O, that will give H3O plus OH minus. Okay. That is the KW. KW is equal to OH minus into H3O plus, and that is equal to 10 to the power minus 14. That you know, this is the formula. Then suppose X is equal to hydroxyl ion. Actually KW is equal to OH, concentration of OH into concentration of hydronium ion, or you can tell H ion, H plus ion. Then what is its molar concentration? Then you simply consider X. Then X is equal for both OH and H. Then X is equal to OH ion concentration, and that is equal to hydronium ion concentration, or simply you can tell H ion concentration. Okay, that is from H2O. The hydronium ion concentration is generated. Hydronium ion concentration is generated first from the ionization of HCl, what they have given in the question. Because HCl plus H2O also it will form hydronium ion. HCl plus H2O it will form hydronium ion. Then that is also giving H ion, and from the water also we are getting H ion. Then that's why the H3O concentration is generated from first from the ionization of HCl dissolved. Okay, that is the HCl plus H2O, that is equal to H3O plus chloride ion. And second from ionization of H2O. In this very dilute solution, both sources of H3O must be considered. Both hydronium ion must be considered. Means hydrogen ion from H2O, hydrogen ion from HCl, both you have to consider. Then what is the total hydrogen ion? Then total hydrogen ion will be 10 to the power minus 8 plus X. X you have considered from the water. Okay. Then total H3O concentration or H ion concentration total, that is equal to 10 to the power minus 8 plus X. Then now you are knowing Kw is equal to H ion concentration into OH ion concentration. Then H ion concentration now became 10 to the power minus 8 plus X, and OH ion concentration is how much? Then OH ion concentration is X. Then H ion concentration is 10 to the power minus 8 plus X. In one bracket you have written, and OH ion concentration again will be X only, X, and that is equal to 10 to the power minus 14, means Kw. Then you have put the value of total H ion concentration and OH ion concentration. Then it became 10 to the power minus 8 plus X, total hydrogen ion, and OH ion concentration is X, again X only. Then that is equal to 10 to the power minus 14. Then now after if you will simplify, then it will take the form of quadratic equation. X square plus 10 minus 8x minus 10 to the power minus 14, that is equal to 0. Quadratic equation. Then from the quadratic equation you know all the already formula, then you will get the value of x. Okay, you will get the value of x after simplifying the quadratic equation. You put in the formula, already formula I told, then x value will come to know. Then OH ion concentration, that is equal to x, and that value will come 9.5 into 10 to the power minus 8, that is the value of x. Then x value, OH ion concentration and H ion concentration in water, both will be equal. Then OH ion concentration x is equal to 9.5 into 10 to the power minus 8. Then now total this OH ion concentration you are knowing. Then POH value you can know. OH ion concentration you are knowing now, that OH ion concentration is 9.5 into 10 to the power minus 8. Then now POH value you can easily calculate. POH is equal to negative logarithm of OH ion concentration. Then OH ion concentration you just write 9.5 into 10 to the power minus 8. Then you will get the POH value is equal to 7.02. 7.02 you are getting the value. Actually you were giving the value importance to get the value of x. Okay, then now you got the value POH 7.02. Then what will be the value of pH? Then pH value will be 14 minus 7.02, because pH plus POH is equal to 14. Then POH value you are knowing. Then pH value will be 14 minus POH. Then 14 minus 7.02, that is equal to 6.98. 6.98. Then this is the, actually I told you these things, hydrogen ion concentration, or you can tell pH value. pH value is now 6.98. Then I have solved two numericals based on pH. Again in next class again I will solve more numericals are there. Then I will focus on numericals only next class. Now I am stopping only here. Thank you.